Hello everyone and welcome back to our videos. Today we will talk about the configuration warning systems. The number of complexity of modern aircraft systems require various warning systems to alert the pilot of malfunctions or incorrect aircraft configuration for a particular flight mode. Most warnings are visual, aural, tactile, or some combination. Warning systems include the takeoff configuration warning, landing gear configuration warning, Mach or airspeed warning, stall warning, ground proximity warning system, and the engine indication and crew alerting system. We will talk about every one of these individually. We will start with the takeoff configuration warning system. Warning system is armed when the aircraft is on the ground and one or more thrust levers are advanced to take off power position. A warning light or aural warning will sound if the stabilizer trim is not properly set. Also, trailing edge flaps are not in the correct position. Any leading edge devices are not properly set. And the last one, the speed brake is not properly stowed. The warning signal stops when all monitor devices are properly set. The second one, landing gear configuration warning system. The landing gear indication lights are activated according to signals from each gear and landing gear lever. A typical system might indicate the landing gear down and locked with an illuminated green light for each individual gear. Another may be a single gear light for entire gear configuration, down and locked indication. When the landing gear is in disagreement with the landing gear lever position, a red light illuminates, meaning that the gear is in transit or in unsafe condition. When the landing gear is in the proper up position and the gear lever is also in the up position, the green position lights go out, signifying an up and locked condition. On some aircraft, a steady warning horn is provided to alert the pilot that the airplane is in a landing configuration and the gear is not down and locked. The landing gear warning horn is usually dependent on flap and thrust lever position. When the thrust lever is retarded and any landing gear is not down and locked, the landing gear warning horn will sound, but can be silent by using the warning horn cut-off switch. Of course, all of these things that related to the landing gear, and we talked about it now, you have already studied at the landing gear chapter 9. The third thing we will talk about is the Mach warning system or airspeed warning system. Some large aircraft are equipped with the Mach airspeed warning systems that provide a distinct oil warning anytime the maximum operating airspeed is exceeded. To prevent the warning, we were reducing the speed below the limiting value, and this is usually the only way to silence the warning. The fourth one, the ground proximity warning system. The ground proximity warning system provides warnings and alerts to the flight crew when any of the following conditions exist. The first one, excessive descent rate. After that, if we have excessive terrain closure rate and altitude loss after takeoff or go around, unsafe terrain clearance when not in the landing configuration, excessive deviation below an ILS instrument landing gear, especially glide slope. After that, when descent below the selected minimum radio altitude. And the last one, wind shear condition encountered. When one of these conditions is encountered, the computer flashes warning lights and sounds an alarm or warning. Number 5, engine indication and crew alerting system. Older commercial airplanes utilize electrochemical system indicators that employ multiple visual and aural cautions and warnings to alert or of hazards conditions such as engine problems or open cabin doors. The new generation aircraft use electronic displays and full-time monitoring system known as ACAS, engine indication and crew alerting system. ACAS reduces flight crew workload by automatically monitoring and recording engine parameters for later review. ACAS provides an improved level of maintenance data for the ground crew without causing the flight crew any extra workload. ACAS usually includes two multi-color display units, two computers, and two control panels. One computer is used at a time for displaying the data on both display units. Computer selection is done on the display select panel. As we see together, this is the two panel of the ACAS. This called the primary or the upper ACAS, and this the secondary ACAS. And as we see here, they show the indication of the engine. Here it shows the EBR, the N1 and the EGT. EBR, engine pressure ratio, and N1, the stage number 1 of the compressor, the EGT, and this the exhaust gas temperature. And you will study these on the turbine engine on power plant book. And the secondary will show N2 and fuel flow. Also it will give us the oil level, oil temperature, and oil pressure, and so many things.